Hello everyone, I am BASNETT, student of Namchi Government College, third semester, BSc Mathematics, and I am here to give a presentation on the topic Determination of Resistance of a Suspended Coil Galvanometer by the method of half deflection and to calculate its figure of merit. Before I start my presentation, it's my great honor to give a presentation on this topic, and for that I would like to thank the Physics Department of Namchi Government College for giving me this opportunity. So coming back to the experiment or the topic, determination of resistance of a suspended coil galvanometer. We have to determine its resistance. Resistance means that opposes the current in the suspended coil galvanometer by the method of half deflection and to calculate its figure of merit. So in coming to the introduction, first what is galvanometer? Galvanometer is an instrument used for measuring current or a function of current by the deflection of moving coil. Essentially, a galvanometer consists of a needle attached to a coil mounted so that coil is allowed to operate freely within the magnetic field created by the poles of one or more magnet. Basically, what it's trying to say is, excuse me, it is an instrument to measure electric current by the help of a moving coil, and it consists of a needle and a coil placed between two magnets, and when magnetic field is created the needles moves and the electric current can be calculated. So what is half deflection method in galvanometer? Half deflection method is the method to find the internal resistance of galvanometer. So why is only half deflection is required in galvanometer? Why it is used? Because it is very simple to calculate and its expression are so simple, so that it is used in the galvanometer. So figure of merit, it is used to categorize the performance of a device. With the help of figure of merit, by calculating the figure of merit, we can say that the device performance is good or bad. So for this experiment, the materials required are a Western type galvanometer. It is a type of a galvanometer, a voltmeter, a battery or battery eliminator, two resistance box, one of 10,000 ohm and 2000 ohm. This one is considered as a resistance and this one is considered as a shunt resistance. To one-way key, a resistor, a screw gauge, a meter scale, ammeter, connecting wire, and a piece of sandpaper. So theory for this experiment is the resistance of given galvanometer as found by half deflection method G is equals to R into S divided by R minus S. So the resistance for the galvanometer is represented by the G. Internal resistance of a galvanometer is given by G, and its formula is R into S divided by R minus S. Here R is the resistance connected in series with the galvanometer and S is the shunt resistance. So the figure of merit is represented by K. As already told, it is used to categorize the performance of a device. So its formula is K is equals to E divided by R plus G whole theta. Here E is the EMF, theta is the deflection produced when the resistance is given, and G is the internal resistance of galvanometer. So the maximum current that can pass through a galvanometer is also given by Z is equals to Nk. Here N is the total number of division of galvanometer and K is the figure of merit. But here only the internal resistance or resistance of galvanometer and figure of merit is required to be calculated. So this third point is not need to be calculated. So for this experiment, the circuit diagram is given as for the resistance of galvanometer. It is like this: resistance is corrected, EMF or the battery, key 1, galvanometer, this is shunt resistance, key 2, and for the figure of merit, resistance, battery, key, and galvanometer are connected. So the procedure for this experiment is that for the resistance of galvanometer by the half deflection method, for this procedure are as follows. The connection should be made as a circuit diagram is given. All the connections should be tied, neat and clean. All connections should be neat and clean, and the initially a high resistance must be given, because if the low resistance is given at the first, then the galvanometer cannot handle a high current, so it can be get damaged. And then by giving a high resistance R, the deflection is given in the galvanometer, and we have to note the resistance and the galvanometer in observation. By giving the deflection, by getting deflection, we can calculate the half deflection given by theta by 2, and we place the value of shunt resistance as always. We have to repeat this experiment for 3 to 4 times, and the procedure or the connection should be same as the circuit diagram. So for the figure of merit, we have to take one battery, cell of one battery, and find its EMF. We have to take a battery and find its EMF by voltmeter connecting positive side to positive side of the cell, voltmeter positive side to the positive side of the cell, and negative side of voltmeter with the negative side of cell, and it is denoted by E. The EMF is denoted by E. Make connection should be same as the circuit diagram, same as this, and the connection, so we have to take a value R and make a deflection and note the value of R and the deflection theta. For this experiment we need R, the resistance, theta, and now we have to change the resistance again and again for 3 to 4 times, and we can note all the results for calculating the figure of merit. Procedure for this experiment is so on. Now the observation, by doing this experiment, we got the observation as follows. This is the real number, resistance, we have given the resistance, and deflection shown by the galvanometer is given like this. Shunt resistance means the small resistance, less resistance we have provided. Half deflection divided by 2, deflection in galvanometer divided by 2, and the formula for the resistance of galvanometer is given by R dot S divided by R minus S, or you can say R into S divided by R minus S. So while taking the value 5000 ohm, we got the deflection 10, and shunt resistance we have put it as a 5, and half deflection theta by 2, 10 by 2 is equals to 5, and by calculating this using this formula we have calculated the galvanometer resistance 5.005. So according to that, for different values we have used a different resistance box, deflection has been occurred, and values are the difference. So here you can see the first we have taken a high resistance, because if we have taken the low, then the galvanometer may be damaged or the experiment cannot be done. So secondly, we have taken more than that, and after that we can get low as we want, but not low as it 1000 ohm or 2000 ohm. It should be at 1000 to 2000 ohm, or else you can say. So this was the observation for the resistance of galvanometer. So for the figure of merit, the needed terms are the EMF of the board, E, resistance, deflection, and the figure of merit. Here figure of merit is given by denoted by K, and K is equals to E divided by R plus G whole theta. Here we have taken the EMF of the board for resistance 5000, deflection given as 10, and the figure of merit we have got is 0.0000799. So according to that, we have placed a different value of resistance, different deflection has been occurred, and different values of K's has been occurred. So for the proper result, we need the average of this all, average of this for both the figure of merit and resistance. So here we have taken the average G1 plus G2 plus G3 plus G4 divided by 4, its average value, and by calculating we have got that 7.79 is the average value of galvanometer resistance, that is 7.79 ohm average galvanometer resistance. And for the figure of merit we have taken the same we have taken an average and we have got 0.0000787 ampere per division, or we can say that 8.7 into the power minus 5 ampere per division into, yeah, 8.7 into the power minus 5 ampere per division. So by doing this experiment, we got the result. The resistance of galvanometer is 7.7 ohm, and the figure of merit of galvanometer is 0.00087 ampere per division. So for performing this experiment, we need some precaution. The precaution are as follows. The all connections should be neat and clean. It should be proper. It should be clean. All plugs in resistance box must be tight. It must be tight, or else the error can be occurred. The EMF of the cell or battery should be constant. Yeah, it's and EMF of the battery should be constant. Why it should be constant? If it is not constant, then the galvanometer fluctuates, so we cannot get the proper value. So for that, we need a constant value, or we can say we need a direct current. Initially, the resistance from the resistance should be higher. As I already said that if the resistance is not higher in the initial position or at the first, then the galvanometer will get damaged, because more current will flow. To oppose the current, we need a high resistance, otherwise the galvanometer will be damaged. And source of error. For performing this experiment, we can get this error. We can get the error if we this did this following things. The screw of the instrument may not be loosened. Instrument may be loosened, so we cannot get the perfect value. The error can be occur of the error. The plugs in resistance box may not be clean. We must clean before doing the experiment, because of the dust and everything. All these errors can be occur and make the experiment unsuccessful. The EMF of the battery may not be constant, as already said in the precaution. This should be constant, otherwise the galvanometer gets fluctuated and we cannot get a proper value of deflection. The galvanometer division may not be equal size here. The galvanometer division, then the difference between the one or two, that division should be equal in the galvanometer. So these are the precaution and sorts of error for this experiment. Now coming to the next topic, the merits and demerits. The merits of performing this experiment is that it is applicable for every DC. You can say that for every direct current it is very useful, and it can be performed by using this galvanometer and this method. And it can have deflection method is very much useful for galvanometer, because it is quite easy to calculate the value by the experiment. The galvanometer resistance expression is so easy that we can calculate it easily. Demerits of this experiment is it is not applicable in alternating current, because it's get fluctuated and cannot be calculated the exact value then when the error occurs. So it has no work in the alternating current. Walkable in high resistance. Yeah, it just need a high resistance. If low resistance is an if low resistance is given, the galvanometer gets damaged, so it has no work in the low resistance. Otherwise, the galvanometer will get burst or get damaged. So here comes to my end of this experiment and my presentation experiment. And I would like to thank you once again to Physics Department of Namchi for giving me this opportunity. Thank you. Wish you all have a good day.